Hi everybody. This video we start to reconcile all the completely inconsistent parts of science which we looked at in video number 1. The fact that gravity is inconsistent with every other part of science is a big problem. It's got to be put together with magnetic fields and electrical fields and quantum mechanics. And also the laws of chaos, completely misunderstood by science. Nobody knows what to do with them or how to reconcile them with the laws of physics. These are not the laws of physics, but they are a description of the physical behavior of matter. It doesn't fit with anything else. That gets sorted in the next video. What about biology? Erwin Schrödinger, What is Life? 1944. He says there's some missing ingredients. He thought quantum mechanics was going to conquer what biology is, but it didn't. It had nothing to say about it. But the laws of chaos do. The laws of chaos show up in biology. So this is the key. But let's tackle gravity first. We need a new description of gravity. Under Newton, it was a mysterious force. Under Einstein, it's the curvature of space-time. And that means it's not consistent with any other part of science. So something needs to be changed. That's what we're going to do in this video. A new description of gravity that makes it consistent with magnetic fields, electrical fields, and quantum mechanics. We need to start again, right from the base. Now we think in language. So if we don't say it correctly, we can't understand it. The curvature of space-time doesn't give you the right idea. The time element is just a distraction. The fact that a clock ticks slower in a strong gravitational field doesn't help you decide what gravity is. So we're going to take time out, put it on the shelf, and bring it back in later. Let's start again and state clearly what gravity is. It's not just the curvature of space. What about the curvature of matter? Isn't the Earth a sphere? Isn't a star a sphere? Space and matter are reactive to each other. Each one curves the other. Now we're getting somewhere. But what about the movement of bodies? And it's got to be consistent with magnets and electrical fields. So here we go. What a gravitational field does is to concentrate the field towards one point, the centre of gravity. But that concentrates, increases the density of the bodies in the field, which increase the density of the field, which increase the density of the bodies. Now we're getting somewhere. Fields and bodies increase the density of each other. That works for magnets. Magnets don't attract each other. Magnets are connected to space, just the same as gravitational bodies, physical matter, is connected to space. They are connected and they exchange information. They must have a common language. Now, there's only one contender for a common universal language. And we express that as mathematics. And that explains why we see patterns all over nature, which are pure mathematics. And we never question the fact that these patterns don't show up in any physics book. Are we blind? We certainly are. Mathematics is the base layer of information in the universe. That's why you see biology on the front of a maths book. But you don't question it until now. So a gravitational field is at base mathematical. It has to be. Space has no physical properties. We're quite used to matter having mathematical properties, positive and negative. Well, space does too. Now it makes sense. So the gravitational field increases the density of the bodies, which increase the density of the field. So when magnets click together, they're aligning themselves with the density of the field. They're not attracting each other. That makes magnetism consistent with gravity. The same works for electrical fields. It's all about communication, exchange of information. That's very, very important to grasp. That suddenly we can bring magnetism and electricity into general relativity, a general relationship between physical matter and space. That's really important. And what about quantum mechanics? Quantum mechanics must be made consistent with general relativity, which is now a consistent body of information. And I want you to notice we've got a little pattern. Magnetism, electricity, a related pair with a unique partner, gravity. That pattern is going to show up all over nature, and we're going to use it as a blueprint to rebuild science. So let's see if we can put quantum mechanics and general relativity together on top of the exchange of information. Now, just before we do that, I want to give you a description of quantum mechanics and general relativity in terms that everybody can understand. Quantum mechanics is like playing a bugle. You play a note. You tighten your lips and try to play a higher note. But you can only play the notes the bugle will let you play. You can't play anything in between. It jumps from here to here. It jumps in energy level. That's quantum mechanics. Electrons can sit here and here and here and nowhere else. In the solar system, planets can move ever so slightly this way or this way. That's like playing the trombone. It's continuous. Gentle movement here, gentle movement there, no problem. So we're quite used to energy level jumps at this scale, but we've just not noticed it shows up in music. So let's have a look again at quantum mechanics. Is that the exchange of information? Well, there are two kinds of particles in quantum mechanics. Fermions, which are the little building blocks of matter, except for the neutrino, and that plays a very important role, which we'll look at later, and bosons. Bosons are the messengers in between the fermions. They exchange information. So we found a common principle underneath quantum mechanics and general relativity, which is the same. That's just like saying playing the trombone and the bugle have a common principle of air, vibrating lips, and an instrument. It really is that simple. Information gets exchanged all around the solar system via the properties of space. If you move Jupiter, that information is transmitted to every other body who adjust themselves according to the density of space. Well, that's like seeing how a magic trick is done. It's almost disappointing. The answer is that simple. It's not simple to get at. It's taken 30 years and lots of people and slog every day. But we got there in the end. So now we've got a common principle between gravity, magnetism, electricity, and quantum mechanics. In the next video, we're going to use that principle to explain the laws of chaos and align them with physics. See you next time. It only gets better.